So, if the cube is empty, otherwise visit succession. Okay, so it will expand all the node in the cube and place all the children of the cube, and in this way it will repeat until all level is covered. Okay, so this is the algorithm initialization. If s is a root node, next fail if open is blank, terminate and failure, select remove the leftmost open, means it will choose the leftmost node, and then it will visit all the successor node, and then it will repeat again and again in a iteration. And this is what a breadth first search. Next, what advantage? What is the advantage of a breadth first search? So breadth first search having a several, okay, advantage. So first, breadth first search will never get tapped exploring burnt alley. Child nodes, and it is visit level wise. Obviously the complexity is so all are to be so would are to be generated in database. So even unwanted node are to be remembered. So that means it will visit all the nodes. Visit all the nodes. First root node, all the child of the, and then the next in this way. Next is depth first. Next is depth first search. It's just a reverse of okay. It's the reverse of a BFS. Okay. So, yes. Any question? Asking any question? So depth first search. Depth first search. Depth first search explore a path all the way to a lift before backtracking and exploring the path. That means starting and it will visit all the nodes. Okay, starting from the left and different way how it travels. Cities travels like this. Choose the leftmost node and goes up to the depth. Okay, so in this way it goes to the depth. Okay, for example, this is a starting node and G is a goal node. Okay, just I'm showing you if this is a tree. If this is a tree, see we're starting with the S is a starting node. First it goes first it goes to, see it goes to is this. Okay, then it visit to this. Okay, so in this way it will visit one by one all node, then backtrack again, it goes to this and then this. Okay, so and this is a technique of a depth first search. Okay, from starting from root node and it will visit all the nodes. Okay, so this is basically the depth first search. Okay, so just like if we write the logic of a depth first search, how to define the logic of the depth first search? Just I'm showing you in a simplest way. Okay, In your book it is written over some algorithm, but most simplest way I'm sharing. This is one of the toughest topic in artificial intelligence, the searching. Depth first search. Okay, so first is the place and the place the starting node S on the cube. So means starting node S on the cube. So the next is if the cube is empty, return failure and stop. If queue is empty, return failure and stop. And if the queue is not empty, if the first element on the queue is a goal node G, return success and stop. This is the algorithm. This is the logic. Okay. This is the algorithm. This is the logic. Okay. And the next is remove and first element and place the children at the front of the cube in any order. Ordering is not maintained. So we'll repeat this step 2. Okay. So this is what a depth first search. We're starting the node with S. S means the starting node. If the queue is empty, then return and failure. If the queue is not empty, if the first element on the queue is a goal node, then return success and stop. If it is not, so remove and expand the first node, means we'll choose the leftmost node. Okay. So in this way, we'll goes to the depth. Okay. So that means it will repeat again and again, and we'll do the same process, means return to step 2. Okay. So this is what a depth first search. So I hope it is clear. This is a searching algorithm. So advantage of depth first search find the solution without expending much path. Okay, so obviously it is better than the breadth first search. Okay, because it takes a less time for searching. Okay. Next is a bidirectional search. Okay, this you don't have a study in data structure. This is this thing, and this are the searching techniques is only applicable to AI. Okay, so bidirectional search is basically it is start searching. Normal searching is DFS, BFS. It is searching starting from always from the root node. Okay, but here the searching start from two direction. That's why it is known as a bidirectional search. Okay, so the bidirectional algorithm is applicable when gathering precedents is easy in both forward and backward direction, and there exists only one or fewer goal state. So this means searching start from root node. This is a root node. Searching start from the root node as well as goal node. Okay, as well as on the goal node. This is the goal node. Okay, so searching start from, so from root node is also start searching, and from goal node is also search starting. Okay, for a specific. So that is known as a bidirectional search. It is used for a specific application. It is not used, for example, BFS, DFS is widely used. Okay, so this type of application is used for a specific cases. Okay, so advantage of bidirectional search, it uses a various technique like a DFS, BFS, or depth limited search. It is efficient and require less memory. Disadvantage, okay, so obviously efficient because searching is performed in both the direction. Obviously it will faster. So disadvantage, the implementation of a bidirectional search tree is difficult. Okay, so real life implementation of a bidirectional search tree is difficult. And bidirectional search, one should know the goal state in advance. Okay, so practically inefficient due to the additional overhead to perform insertion operation at each point of search. Next, so bidirectional search is over. The next is heuristic search. Most important. If few important question in artificial intelligence, obviously we can say is a heuristic search, because heuristic searching technique is one of the searching techniques which is used in AI only. Okay, so heuristic search. Already I have from the first class I have telling you this keyword heuristic. Okay, heuristic knowledge I have given on the first class: declarative knowledge, procedural knowledge, and heuristic knowledge. Okay, so what is heuristic? So heuristic means basically uninformed search is inefficient in most of the cases because they do not have any domain specific knowledge about a goal state. So heuristic search uses domain dependent heuristic information beyond the definition of a problem itself in order to search space is more efficiently. So that means heuristic search is informed search. So information about the problem domain is available. Okay, so simply heuristic search is used for a good judgment. Okay, heuristic search is used for a good strategy, good tricks. Okay, so in a heuristic search, one function is used. That function is known as a heuristic function. That function is known as a heuristic function. So deciding which node to expand next. Instead of doing expansion, for example, in BFS and DFS, BFS is follow a breadth first search techniques. It follow a specific order. DFS is a breadth first search. It also follows a specific order. Okay, but if we don't want to follow a traditional technique like a BFS and DFS, okay, if we want to traverse using some heuristic information, okay, so for that heuristic search is used. Okay, in this course of expanding a node, deciding which successor or which successors to generate instead of blindly generating all possible successor at time. So deciding that certain nodes should be discarded or pruned from the search spaces. So informed search algorithm uses domain knowledge. In informed search, problem information is available which can guide the search. So that is what a heuristic search. See, what is heuristic? Heuristic is a criteria, method, and principle for deciding which among several alternative course of action promises to be most effective in order to achieve some goal. So heuristic information, see where this heuristic technique is used. Okay, Heuristic technique is widely used in artificial intelligence. Okay, nowadays AI technique is widely used. Nowadays, the any software. Okay, nowadays Google is using the AI based searching techniques. Nowadays, different plagiarism software, they are using AI based techniques. So AI based technique is basically it uses a heuristic search. Okay, heuristic means basically some of the information is already available. Okay, some of the history of the previous knowledge is already available. As per the previous knowledge, it will perform their operation. So heuristic function. So how heuristic search will work? Heuristic search is work using heuristic function. Okay, so heuristic information is provided in form of a function is called heuristic function. So heuristic is a function which is used to inform search and it find the most promising path. See here, in normal BFS, DFS, we'll choose a traditional path. But in heuristic, we'll check which one is the most prominent path. Okay, so it takes the current search state of the agent and input and produce the estimated how to close agent from the goal. So heuristic function estimate how to close a state is to the goal. So it represents both h of n. H of n is basically the function name. H is a name of the function and n is the argument. So it calculates the cost of the optimal path between the pair of state. So heuristic method, however, might not only give the best solution, but it guarantees to find a good solution in a reasonable time. So heuristic technique is basically a good judgment techniques. It is the best techniques. We use the concept of a heuristic information. It uses the concept of a probabilistic information. Okay, it uses the concept of a probabilistic information. Is this clear? Heuristic. So in next slide, it is also heuristic. Yes, heuristic function. So heuristic function at a node n is estimated of the optimal cost from the current node to a goal node, denoted by h of n. So h of n is the estimated cost of the cheapest path from a node n to node goal node. Estimated cost of the cheapest path from a node n to a goal node. So heuristic search, see this is a searching space. See, this is a search space. This is a search space. Okay. This is the initial state. These are the different actions. And these are the different goal nodes. The red one is a goal node. We'll start from the green. That is the initial state. Okay. So in general, start state is represented by a 5 tuple. S0 O G N is a 5 tuple. So every tuple having some identity. For example, S is a set of possible state. S of 0 is a start state of the problem. O is a set of state transition operator, each having the same cost. G is a goal state, and H of function is a heuristic function. So this is what a heuristic search. So this is the formula of a heuristic search. H of n. H of n is basically will input some heuristic value and it will return the some good judgment or best path. Okay, which path is the best? Next, we are coming to a different algorithm. We have a 2 more algorithm. So in a first half, means first in first class today, I will take a 2 class. In first session, we'll complete the search. Okay, and next session we'll deal with a block 2. Okay, so base first search, because in your syllabus we have a AI and ML. Okay, from next class we'll start with the ML. Okay, we'll not deal with the AI. So AI will cover on today. Two booklet for AI and two booklet for ML. So best first search. What is best first search? So best first search is basically the heuristic informations are there. It is an informed search. Okay, best first search is basically it uses the evaluation function f of n that gives the indication of which node to expand the next for each node. So every node in a search phase has an evaluation function, which is known as a heuristic function associated with it. A heuristic function h of n for each node indicates how the node is from the goal node. Okay, so from each stages, it is trying to find out the most promising path. Okay, so that is what a best first search. Just so best first search. So BFS, both are BFS, but one is a breadth first search, another is a best first search. One is an informed search, another is a uninformed search. So place the starting node S on the queue. Yes. So we are dealing with the what? Uh, best first search. So first of all, best first search is a informed search. Some of the information is available. Okay, prior information is available. So the algorithm for the best first search, first the place the starting node is on the queue. So that means from the tree, it will start from the root node. Okay, if the queue is empty, return failure and stop. Return failure and stop. Okay, third is if the first I think I have not shared. Yes, I think it is visible. Yes, yes, it is visible. So first of all, place the start node is on the queue. If the queue is empty, then return failure and stop. If the queue is not empty, then if the first element on the on the queue is a goal node G, then return success and stop. return success and stop. Otherwise, otherwise, otherwise means if it is not work, that is otherwise, then remove the first element on the cube. Remove the first element from the cube, expand it and compute the estimated goal distance from each child, and place the children on the cube. Step 5 is repeat to step 2. So here the difference is here whenever we are expanding, we are computing the estimated goal distance from each child. So here we use a heuristic information, okay, which we don't use a best first search or depth first search, okay, and that is what means for each node we'll check the distance from the goal node, okay, and that is using the function, use a heuristic functions. So this is means we can say in BFS is depends on the heuristic to select most promising path to the goal node, okay, most promising path to the goal node, okay. So it use a heuristic information, and heuristic information is used to find out the goal node, and that is what a breadth first search, best first search, not breadth first search. This is a best first search. I hope it is clear. This is the advantage of best first search. Best first search, obviously, it is we can switch over to BFS, TFS. It is a better than the more efficient than the BFS and DFS. BFS and DFS is a traditional algorithm, okay, which is widely used in data structure, breadth first search and depth first search. So best first search provide a better efficient than the breadth first search or depth first search, but it has several disadvantages. That information is available, but what type of information is available, it can create a problem also, because maybe information consists of a metadata, information having certain not directly available. So that is basically, it is good for searching, but it is a probabilistic searching. So if the probability is giving a wrong return, so it become unsuccessful also. So chances of getting stuck in a loop is higher, okay. It can behave as an guided depth first search in worst case scenario. The next is A asterisk. There's the last one, A asterisk search. Okay. So what is A asterisk search? So A asterisk search is also basically the guided search or information search. It also use a heuristic function, but the formula of A asterisk and formula of a best first search are different. Okay. So A asterisk search is the most commonly known as in the form of a best first search. It uses the heuristic function, and the cost of reach to node n to from the starting state goal node G of n. So it is combined feature of a uniform cost search and greedy best search. by which it solves the problem efficiently. So AISTIC search algorithm finds the shortest path through the search space using heuristic function. Okay, so function of n equal to g of n plus h of n. Okay, so this is a formula. See, this is a formula of this A asterisk search. This is the formula of a asterisk search. Okay, this formula is basically f of n equal to g of n plus h of n. Okay, so what is this f of n? F of n is basically a estimated cost of the cheapest solution. Estimated cost of a cheapest solution. And h of n is basically cost to reach a node n from the starting node. Okay, and the cost of reach from a node n to a goal node. So it is divided the function of n equal to g of n plus h of n. Okay, so g of n, and so AISTIC algorithm is evaluated function of n is defined as function of n equal to g of n plus h of n. So g of n is basically sum of h cost from start node to a end node. H of n is basically the estimated lowest cost path from a node n to a goal node. Just I'm explaining its algorithm. So A asterisk. So basically A asterisk algorithm is not a new algorithm. It is a modified form of a best first search. Okay. It is a refinement model of a best first search. Okay. So A asterisk and best first search both use the heuristic information. Okay. So algorithm is first place the starting node is on open. Okay, place the starting node is on open. Next, if open is empty, if open is empty, then stop and return failure. Okay, third,
Sir, if you're sharing your screen is not visible.
Okay, screen is not visible. Okay.
No, sir.
Okay, I forget to see. So, yes, A asterisk, like all this algorithm, first of all, you have to start with a starting node S. Okay. Next, as per the algorithmic concept, if is empty, then return and failure. Okay. If it is not empty, then remove from open node n that has the smallest value of yes. So this is basically check. Okay. The smallest value of f asterisk n. So this is again is using a function. Okay. So if the node is a goal node is a goal node. Okay. Then return success and stop. Okay, and if it is not a goal node, that means it is otherwise. It is otherwise. Okay, So otherwise you have to expand. Okay, expand n. Okay, and generating all of its successors in dash enders and place in on closed. Close. For every success of n dash, every successor of n dash, okay, uh, if n dash, if n dash is not already open or closed, open or close, attach a back pointer. Attach a back pointer to n, and here it will compute again the f star n dash. And the next is if n dash is obviously it is 5. So each n dash that already that already on open or closed should be attached to a back pointer. Back pointer. Which g of n dash, obviously this will also be a g asterisk. Okay, so it will repeat 6, return to step 2. Basically this is nothing but it is a BFS, but here it follows some nested operations. Okay, so here we will calculate the h star n and g star n. Okay, so means it follow backtracking also and the forward tracking also. So here use the formula which is already discussed, means the f star n equal to g star n plus h of h star n. Okay, so this is what a formula. So that is what a asterisk algorithm. So this is what a asterisk algorithm. Once again, I'm writing the formula of the asterisk algorithm. That is f star n equal to g star n plus h star n. So in normal VFS, only we use a H star n. But in AISTICS, we have used both. This is the difference. It's a more refinement. Okay, both are used the concept of a heuristic informations. So I hope it is clear. I hope it is clear. So searching is complete. So next we'll discuss on the second session. So second session we'll discuss the rest of the part of AI, that is a knowledge representation. We'll discuss first order predicate logic, and we'll discuss various causal forms. And if you have any doubts, that we'll also discuss in the next hours.
Uh, yes, sir. So we can stop the recording this session from the regional center. And this is an announcement, though I have mentioned in the chat box also, but this is an announcement for all those who are regularly attending the class. No class on. Instead of that, today you will have a second class after a 10-minute break. So by 3:30 we'll start with the second class, and it will come to an end at around 4:30, 4:45. So please be here. Don't log out and wait for 10 minutes. 10 minutes break for you and for the resource person as well, because resource person has other engagements on 15th. So we are preponing the class to today itself. 7 minutes, yeah.
Okay, okay. Thank you.
Thank you, sir. Thank you. Please don't log out, all students. Please be in the class and we'll start in a short while. Yeah. Rohit, you can stop the recording as of now and resume the recording after the class begins.
Hello, ma. Um, I think the lecturer is not around. Class captain, Sylvester, what is happening? Why is the lecture? I cannot hear anything again.
Wait for 5 minutes now. The lecturer is coming. Please be able.
Okay, thank you. Yakubu. Hello, ma. Please, I have a question. By what time is our first class going to introduce since we have double class today? Hello, is anybody here? Please.
That's what are you saying?
So now we'll discuss knowledge representation.